So we are talking exponents, right? So remind me what you already know about exponents. Don't be shy.
Like just like anything.
Anything you like.
It's like
They are numbers and that you. Well, they're not like they're numbers.
What
like,
does x to the power of 3 mean?
X cube, like x and x cubed.
Yeah, x multiplied by x multiplied by x. How can I simplify x cubed multiplied by x squared?
it's 5.
X to the power of 5. Yeah? All good for you? If I did x to the power of 6 divided by x to the power of 4, could I simplify that? X to the power of 2. Okay? Everyone all right with that? Anyone need to a refresher just on why? Do you all know why? Yeah? No?
I don't.
So if we do x multiplied by x multiplied, I always pick a number and then regret it. Right. Divided by.
Oh, then you cross it out, right.
But I want to know when you cross it out, what are you doing?
Canceling each other out.
Because technically that's just like you can split it up into x over x, x over x, and that's just all one. So.
That's what I like. We could have x divided by how we work with fractions. It's always good to make links. This x is divided by this x. Then we multiplied by this x divided by this x. And then we can multiply by this one. The splitting fractions thing. And then we've got that. And then finally, we're left with, we can put them over ones if necessary. Yeah? And what happens? So this is important. It's this cancelling out aspect. I will still say cancelling out. It is cancelling out. But cancelling out doesn't mean poof, magic, gone, disappeared. We can't just wipe it away and pretend it never existed. All right? What is x divided by x? This is 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by x multiplied by x. Okay? So that explains why this would be x to the power of 6 subtract 4, yeah? Because out of the 6, 4 of them cancel out. So we can subtract. Okay? Easy enough. Then we, I guess, looked at, well, what if we've got x to the power of negative 3?
Right.
1 over x cubed. Remember why? Well, I would explain it like this, using our criterion B, pattern spotting. Right? X to the power of 1 is equal to x to the power of 2 is equal to x to the power of 3 is equal to x. I don't like times, by the way, but you carry on.
X multiplied by x multiplied by x multiplied by x.
How do I move up? So what do I do to go from x squared? What do I do to get to x cubed? Multiplied by x. Okay? So as I move up my list, I am multiplying by x. Right? What if I wanted to go the other way? So I want to go from x to the power of 4 to x to the power of 3. Divide by x, yeah? Or, yeah, same thing. So if we divide by x to come back down, then we must be able to follow that pattern through, yeah? Divide by x. So, what's the next one down? X to the power of 1, x to the power of 0. x divided by x is 1, not x. That's why any number to the power of 0 is equal to 1. There's my explanation for that. What happens when I go further? I get x to the power of, so what do? I divide by x, and I get 1 divided by x. If I wanted to do x to the power of minus 2, I've got to do 1 divided by x divided by x. Now, some of us don't quite know how this is done. So what was the other way of dividing by x? So let's do multiply by 1 over x instead, and we end up with 1 over x squared. Okay, so that gives us our negative. Some people are writing. Obviously, you want to make these notes because you weren't sure. Some people are not writing. I'm going to presume you guys are 100% happy with this, and it won't be a problem if I gave you a quiz on it. There is a video, of course. You could turn around and go, I'm going to make the notes at home when I watch the video. I choose to listen. That is entirely up to you. As long as one of those things is going to happen. Do I need to pause at this stage? Yeah. We should be able to do, if we've got x squared cubed, what does that mean and why? So that would be x to the power of 6, because do you know why you multiply them? Exactly, it's x squared multiplied by x squared multiplied by x squared. Okay. All right. That has the same result as doing x to the power of 3 squared, or does it? Is that always true? That's an important one. Yeah. 2 multiplied by 3, 3 multiplied by 2, same thing. Okay. So we've got that. Right. Hopefully then, we also know that x to the power of 1/2, more difficult to explain, we won't go into it now, but it is the square root of x. So 4 to the power of 1/2 is 2. The square root of 4, which equals 2, or negative 2. Do you know what x to the power of 1/4 would be? Yeah.
The 4th.
Yeah. The 4th root of x. Right.
Do you think you could try to explain why x to the power of 1/2 is the square root of x?
I can do it next time if you wish. I'm not going to do it now because it will just take us into break time. Not break time, next lesson. All right, so we got that. Good. And it's saying as well that we should be able to evaluate things like, I'm looking in the book, 2/3 to the power of -2. Anyone know? Because there's 2 parts to this. The first part would be to apply the power to both sides. Because if I made it 2/3 to the power of 2, not -2, that would just be the same as 2/3 multiplied by 2/3, yeah? Which is the same as 2 squared divided by 3 squared. So we apply it to both. So we've got the same thing here. We can do it as 2 to the power of -2 divided by 3 to the power of -2. And then what happens? No, the powers don't make positive in that way. Well, the numbers aren't negative either, so the negatives are only to the powers.
It's just like over one or something fraction.
Yeah, so do you remember what 2 to the negative 2 is? Right, so let me try and explain. So this would be 2 to the power of negative 2 multiplied by 1 over 3 to the power of negative 2, yeah? Which, if we were to rewrite that as 1 over, or 1 divided by 2 to the power of 2, we've got that bit from before, multiplied by, what would that be? 1 divided by 1 divided. That would actually be 3 to the power of 2. And if you then look at it, we would then end up with 3 squared divided by 2 squared. So if you now just compare where we were with where we end up, you can make a kind of shortcut judgment. Just switch it, yeah. But it's not just being switched because we fancy the idea of switching it. There is a mathematical process to it, yeah? Get that? Right. Go on. Because I split this fraction into what makes the fraction. So another example would be, what would 2/3 be just as a fraction? That would be 2 lots of 1/3, right? So I just broke it up like that. Okie doke. Right. I'm going to leave the video recording so I've got proof. If any of that's a bit of an issue, because we want to move on for the rest of it, next lesson, review that, review the video, make your notes, come and ask for any help if you wish to get these things sorted. If you allow yourself to move on without this being sorted, then you will struggle. Okay?